Welcome to Study Loop.
The inductance of a coil L is given by mu naught n squared times A over 2 pi r, where n is the number of turns in the coil, A is its cross-sectional area, and r is its mean radius. So if we wish to find the number of turns n, we can rearrange this equation. The number of turns in the coil is equal to 2 pi r times L over mu naught times A. And these values are all known, so we can substitute them in. So putting our values in the equation and suppressing the units, we see that the radius is 12 centimeters, so 0.12 meters. And the 2 pi cancels with the 4 pi in the mu naught. The inductance is 0.1 times 10 to the minus 3 henries. So all our values here in SI units. Mu naught, the pi's cancel, we're left with 2 times 10 to the minus 7 in SI units. And the cross-sectional area is 0.6 times 10 to the minus 4, and that's meters squared. And hence we get the number of turns in the solenoid to be 1 times 10 to the power 3, and that is 1,000. So there are 1,000 turns in the solenoid. So next, we have the resistance per unit length, and hence if we calculate the total length, we can calculate the total resistance in the coil. So we know that the cross-sectional area is equal to pi times diameter squared over 4. And we know the circumference, C, is equal to pi times d, so the circumference of one of the circular surfaces. So this implies that C is equal to the square root of 4 pi a from above. And this is equal to the square root of 4 pi times the cross-sectional area of one turn, which is 0.6 times 10 to the minus 4 meters squared. So if we have the circumference of one turn, which is 0.02746 meters, we can hence calculate the total length of the wire. And so the total length of the wire is equal to the number of turns, which we calculate to be 1,000, and the distance around one turn, which is 0.02746 meters. Hence we get the total length of the wire to be 27.46 meters. And since we have the resistance per unit length and the total length, we can calculate the total resistance. So the total resistance R is equal to the resistance per unit length, 0.076 ohms. That's actually ohms per meter, multiplied by this total length of 27.46 meters, gives us a total resistance of the solenoid to be 2.09 ohms.